For the lens thickness problem, we're given the three presses here, their sample means and their standard deviations, and it says they're all based off a sample of size 5. If you had not been given X bars and S's, you could plug each data set into your calculator separately to find them, but we are provided those numbers here. So before we can find any of our values, let's go through and find our degrees of freedom. So I've already written down that K is 3 because we have 3 groups, N is 15 because we have a total of 555, so 15 data values. So the first degrees of freedom is 3 minus 1, which gives us 2. The next degrees of freedom is N minus K, which gives us 12. Notice if you add 2 and 12 together, they add up to 14, and that should be N minus 1, so 1 less than the total amount of data. The next thing we can do is, in order to get SSB, we need these 3 means from the table, but we also need the grand mean. So if you take each of your means and multiply back by the sample size, which here they're each 5, what we will be able to do is really get how much all the data would have added up to in the first place. So we're taking each sample size times the mean, and then we divide by the total amount of data, which is 15. This overall or grand mean here will be 23.7113. Just as a little note or like a hint, when you find that number, it should be somewhere between these other values that we have here because it is the average of all the data. So SSB is then sample size, so 5, times the mean for that group minus the overall mean, and then you square it. And we do that for each of the groups. So we'll have 3 terms here because we have 3 groups. And this number is just giving us a sense of like how different are we from middle to middle, or how different are those centers of the individual data sets. Okay, so this is what SSB should look like here. And if you go through and calculate that, you will get 10.517. So we'll put that in here. These are called between or group and within our error, so I added that little bit there. SSW, which then measures like how spread are we in the group, so think of like how wide are the box plots, is sample size minus 1 times S squared. So the S's in the table are our standard deviations. We do want to make sure to square them, and sample sizes out front are 5 minus 1. So again, we have 3 terms because we have 3 groups. Okay, this is what SSW will look like, and this should give you 26.152. Then if you add those two together, we get SS total. So if we just add 10.517 and 26.152, you get 36.669. Now to get the mean squares, they are the sums of squares divided by their degrees of freedom. So the 10.517 over 2, and the other one is the 26.152 over 12. So those are going to give us 5.2585 and 2.179. Then finally, F is the ratio of those two numbers, 5.2585 over 2.179. And that will be 2.413. So if you use this table structure, which is called an ANOVA table, it's kind of handy in keeping track of all your numbers. And once you have the degrees of freedom and sums of squares filled in, all you're doing to get the rest of the table is dividing. Finally, we need the p-value. So we go to StatKey, and we will look in F. You'll enter the 2 degrees of freedom in order. They were 2 and 12. Click OK. This will always be a right-tailed test. And then we enter our test stat of 2.413. Click OK. And we see we get a p-value of 0.132. So what we would say here, because our p-value is greater than a 5% significance level, is that we failed to reject the null, and we do not have significant evidence of any differences in the population mean lens thicknesses for the 3 presses.